Hey guys, I hope you're all doing well and staying safe. In this video, I'll be going over the practice problems I have provided for exam 2. And so basically, I just go through the solutions. I was trying to record previously and it didn't work out. So I started solving out some problems, but I'll just go over them again. And I did want to mention that I'll post the practice problems online, as well as a cheat sheet I created a while ago for acid-base equilibrium that may be of help to you. So also, please don't hesitate to email me or ask me any questions, whether it's about this or something else. So as far as question 1 goes, it's asking to figure out the value of Kc given that we have K forward and K reverse. And then I said that Kc is equal to Kf over Kb. And another reminder that I try to stress my best is always balance your reactions. Do not think that every equation that you're given or reaction that you're given is going to be balanced. So, and that's one place where people tend to miss points, is because they did not balance the reaction. So basically, in this problem, it's just plug and chug. You get 7 over 2, and which is equal to 3.5 moles over liters. So as far as question 2, it's asking write the mass action expression, or QC, for the following chemical reaction. Remember, QC is the denotation for the constant when it is not at equilibrium. Okay, so again, balanced reaction. So here, this reaction is not balanced. So I wrote it out to be 2C2 plus 4I minus, and that yields T2 copper iodide plus iodide. And remember, Q is equal to products over reactants. So in this case, it will be I2, but we do not include any solids or pure liquids in our expression. So always remember that we do not include these. So in this case, it will be I2 again over Cu2 plus to the power of 2, because we have that coefficient right here. And then it will also be I minus to the power of 4 because of the 4 here. So that gives us the answer for number 2. So number 3 goes over various equilibrium constant data at 25 degrees Celsius, and it's asking what is the value of Kc at this temperature for the reaction. So let's call this reaction 1, and this is reaction 2, and we're trying to find the Kc of reaction 3. So Kc1 is equal to HSO3 minus over. And I did make sure that the reactions are balanced, so just to clear that up. Yes. And that was equal to 9.1 times 10 to the negative 10. Okay, so, and for number 3, the equilibrium constant expression would be So, how do we combine these two reactions to give us an equilibrium expression such as this one? Basically, what you'd have to do is make something like KC2 times 1 over KC1, because that would mean we are canceling out this with this to get rid of H2SO3, and then actually I'll just write it out. And so to cancel out, if we did this over 1, then that would mean this would cancel out with this, and the 2 right here would cancel out with this, and that would leave us with this expression right here, and that will let us figure out KC3. So in this case, it's just multiplying KC2 times the reciprocal of KC1, which would be, let me write this, (9.1 times 10 to the negative 10 over 1.4 times 10 to the negative 2, and that will give us 6.5 times 10 to the negative 8, and that is our answer for the equilibrium constant for the third reaction. So I hope this is making sense so far. We'll move on to the next question. So the equilibrium constant Kp for the reaction H2 plus I2, which yields 2HI, is 55.2 at 425 degrees Celsius, and it's giving us at that temperature, if it contains 0.127 atmospheres of hydrogen and 0.134 atmosphere of iodine, and another value for hydrogen iodide is the system at equilibrium. So this is going to be a comparison between Q and K, correct? So that would mean our reaction is H2 plus I2, which gives us 2HI. Let's figure out. We know that the K value is right here. It's 55.2. So our Q expression would be PHI over PH2 times PI2. And that would mean it is over 0.127 times 0.134, 65. In this case, Q which is equal to 65, is greater than K. That means it is not at equilibrium, and it's greater than the expression, the K value, and it would have to go backwards to establish that equilibrium again. So if you think about it, if K is here, and if your Q is lower, it will have to go forward. If your Q is bigger, it will have to go backward. Okay, so it will have to move towards the reactants. So I hope that makes sense. I'll move on to question 5. Here they're asking the equilibrium constant Kp has a value of 6.5 times 10 to the negative 4 at 308 kelvins for the reaction of nitrogen monoxide with chlorine. What is the value of Kc? So this is pretty straightforward. We have the Kp value, and we have the temperature, correct? So this should ring in your head. The formula Kp is equal to Kc times RT delta N. Delta N here is the change in moles. In this case, we'll start plugging in. So we have 6.5 times 10 to the negative 4 is equal to Kc times 0.0821. That is our R constant, correct? Remember to make sure you know the difference between the two R constants. One is in joules and the other one is in liters times atmospheres over moles times Kelvin. So we will multiply this by our temperature, which is in kelvins, and here we have 2 moles of NO and 1 mole of CO2, correct? And in the product side, we have 2 moles of gas. So delta N is the mole change in moles of gas. So this would be 2 plus 1 minus 2, which is equal to negative 1. So we'd raise this to negative 1. And when we solve for this, we'll see Kc is equal to 6.5 times 10 to the negative 4 over and that will give us 1.6 times 10 to the negative 2. So that is our answer. Then we'll move on to number 6. So number 6 is asking, sorry, this went over 2 pages. So what is the equilibrium concentration of Ml2 2 plus in this reaction? So make sure it is balanced. It is, okay. So this question is gonna be the one where we used something called the ice table. So in that case, we're trying to find the equilibrium concentration of one of the products, and so we're gonna have to figure out the initial moles of M2 plus and 2L. So I'll begin with that. moles M2 plus is equal to 0.1 mole per liter times 10 milliliters, and that should give us 0.001 mole. And then we have the same thing for 2L. .1 times 10, oops, 1, which is equal to same thing. Then we begin our ice table. So we have M2 plus 2L gives us ML2 plus 2.